No, Mike, I got to ask them this because I do this. You know me, you know I'm not a sports fan, but there is one sport that I follow quite religiously. Anybody here a car race fan? Anybody follow Formula One at all? Yeah. Really? Surprised. I don't see not that many, though. I think I saw one. How many? Anybody here? No? Nobody cares? What do y'all follow, that wimpy crap? What is it, football, baseball, hockey? That sucks, too. So my group of Canadian friends over here probably want to kill me right now. How are you guys doing in hockey anyway? I heard it started out good and then you sucked all the way afterwards. What, did Sweden beat you guys or something like that? Formula One is the only true sport. That is a man's sport. Montreal. Yep. Did you see Monaco last week? Yeah. The guy that lives there, Nico Rosberg. And then before that, it was Spain, and the guy that lives there won Spain. Everybody see a pattern here? It's funny the way that works sometimes. I don't know if it's the the adrenaline rush that because racing a Formula One car is not adrenaline enough, right? So you get that additional high when you're at your home location. Last year, the Japanese driver didn't do very well, but he won the Japanese Grand Prix. So it's interesting when somebody from that country actually wins the Grand Prix of that country. I don't think there are any Canadians in the circuit this year. It'd be called Formula 1A. I just made that up. That was pretty good, huh? All right, let's get started. Enough fun. Thank you, ladies. All right, once again, full disclosure, this is not an advanced dependency injection talk. The purpose of this talk is to get everybody into what dependency injection is, and more importantly, to sell you on it, to tell you why it is you need it. This is not something that is in the back burner anymore. This used to be at one point the cool kids term. Everybody was throwing out the DI word about inversion to control, dependency injection, throwing out those buzzwords around, something that the quote-unquote cool kids on the block were using. It was a little bit intimidating at one point. It's now mainstream. It's completely mainstream, and it's something that every application benefits from, and everybody should be using it. So, anybody here see any of my sessions in the past? Really? Repeat offenders, huh? And you actually came back. Where did you see me? Oh, which one? This year? Okay, cool. Well, welcome back. Good to see you again. That's always a fun conference, too. Nice and small. I can curse on stage on that one because they're not recording anything. There's no evidence. All right, my name is Miguel Castro. This is my, It's my 6th TechEd. Judging by the way this has gone so far and what the evidence on the tape is, it'll probably be my last. But I've done this, about 6 times now, and I speak at all the regular conferences around the country. So some of you might have seen me at Dev Connections or VS Live like this gentleman, or all sorts of different ones. You like my conference Cuban picture? Isn't that great? On the non-Microsoft ones, where they force us to look semi-presentable at this conference, but on stage I usually wear that stuff, and I'll just stand there on stage with it. All right, so we're going to talk about what dependency injection is, but more importantly, how we get there. Why is it necessary? Because there's kind of a problem space that needs to be solved. There's a reason that we use dependency injection or the associated product known as a dependency injection container. We're going to talk about both things, the concept of it and the product part of it. But there's got to be certain groundwork laid out because there's problem spaces that we're trying to solve, and there's a reason that we're using dependency injection, and we're going to go through those problem spaces, and this has to do with abstraction and class coupling and testability. Everybody here has heard the term testability, right? Testable code. It's another buzzword that's been in our industry for a while now. Everybody wants to write testable software, but there's a kind of a myth, a misconception that we use dependency injection containers to assist us with testing, and that's actually a very inaccurate statement. The dependency injection container is used in production, setting our groundwork up for dependency injection in concept and design is what allows us to write testable software. And I'm going to get into more detail about that, including showing you what a unit test would look like in a case of dependency injection. And then we're going to talk about the product behind this. This isn't a product pitch. This isn't a product sales talk. Dependency injection containers are all free, and they all do pretty much the exact same thing. They're very, very competitive. So when Microsoft adds a new feature to Unity, for example, who's a Unity user here? Anybody? Okay, it's a great container. It does just about anything you need. So does Castle Windsor. So does Ninject. The minute Microsoft adds something to Unity, the guys at Road Castle say, oh, yeah, watch this, and they add something, and then they add something on top of that. Then the Ninject guy comes up, and he adds something to Ninject. So, looking for a container today is all about just finding the one you're comfortable with and the one whose syntax you like. And I'm going to show you examples of all of these just in quick syntax differences, so you see that at their base, they're all pretty much the same thing. They just differ a little in syntax. There is one exception to that, and that's MEF. Any MEF users here, or MEF heads as we call them? All right. So I'm a MEF head, okay? And it's the dependency injection container of my choice. A lot of people will argue that it's not a true dependency injection container. Honestly, I'll beg to differ, because it does exactly what I need for it to do as far as my DI requirements are concerned. There are a couple of things that it may not do, and we'll talk about them here and there. But to me, it works perfectly fine. But the way MEF works and the way it sets itself up is a little different from the other containers, so we're going to go through a little more detail there. And then the final part of this is, in my opinion, the most important one, which is the actual usage. Now that I've taught you all this technology, what do I do with it? Now what do I do, and how do I integrate this into an application? So I'm going to show you examples of DI usage in 3 different types of applications. The 2 more important ones are XAML applications and ASP.NET MVC. But are there any web forms developers left here? Notice I said left here. It's not a legacy technology, so I should take that statement back. All right, web forms is alive and well. It's still going strong, and it's a great technology, and you can do dependency injection with web forms. So anybody that says that you can't, and there's been a lot of pundits that say that you can't, is dead wrong. It's hard to test web forms, but you can still do certain DI things with web forms, and I'm going to show you how to do it. So with that said, let's talk about the problem space here, and that is all about class coupling. Now, a lot of stuff is going to be not new to you. You're going to understand this because I'm talking about the quintessential problem with class coupling that we've all been taught for a number of years now, which is one class depends on another, and now they're completely bound to each other. They're coupled to each other. And it's hard to write any kind of code without having some amount of coupling. The minute we say int x equals 5, we've just coupled some code. But some stuff we can't get around. But if you have a class that's coupled with another one, now that's a true solid dependency there, which means, number one, there's a compilation dependency, which means you can't compile one without the other. Number two, there's a behavior dependency, which means if you need to run one class, you're locked into the implementation of the other one, because the 2 are completely dependent on one another. So I'm going to show you all this in code. And with that being said, I'm going to ask you permission for something. If I switch over to code now and not go back to slides, is anybody going to have a problem with that? No? Does anybody prefer that? Round of applause if you do. That's what I thought. I have to have these slides because, Microsoft wants me to send them a slide deck, right? You hear that, Microsoft? Where's the damn microphone? But I actually prefer to show you this in code and just stay in the code because I think you get a lot more out of it. So bear with me with the crudity of this example because I want you to concentrate not on the implementation example, the line of business part of it, which is e-commerce, but I want you to concentrate on the technology behind it and what I'm trying to explain, okay? So I got this class here, these classes here. My whole problem space is about e-commerce here, okay? I have the concept of processing an order, and when you process an order in e-commerce, you undergo several steps, and these steps can be broken out into kind of autonomous steps. You have the concept of updating customer records on what product they ordered and what, changing inventory amounts, that kind of thing, generating invoices. You have the task of notifying the customer. That famous email we get from Amazon when we press the place order button, right? Thank you for ordering this. That's a notification. You have the processing of our credit card. That can be kind of a standalone process. So I've taken all these different things and I've broken them out into 4 different classes. Now, the classes don't do anything, so you're going to see basically just stub code, okay? But I got a class, for example, called Billing Processor. And notice the job of this class is, to process a payment. You give it a customer number or ID or whatever, and the credit card information and a price, and you're going to run a credit card through. Now, in reality, obviously, I'd be running a credit card through here. Anybody want to hand the credit card over and I can test this? No problem. I got a customer class here. Oops. Customer class, the job of the customer class is to update customer order. So once again, part of the e-commerce process for processing an order, but this is a subtask that can stand on its own. Then I got this notifier class here, whose job it is to send out the email receipt to the customer. And in between all those steps, I'm going to be logging some information, maybe logging to an application event log or to a SQL server for audit trail or whatever, but I got a logging class here whose job it is to simply log a message saying I did something. So I got all these 4 different steps, and these are all handled by this one class called the commerce class. And this class, the beauty of this class is that it's an orchestrator class. This is the one class that my host application has to instantiate in order to process an order, because all it has to do is build an order info object, which is the big package of data, and call the process order method. And from there, I'm going to depend on the billing processor class, the customer class, the notifier, and the logger class. And then I'm going to go ahead and call process payment, update customer, and all that stuff. Now, some of you, if not all of you, are probably already starting to see the problem here. Number one, we have accomplished some pretty successful and bad coupling here, because these classes are all dependent on one another. I cannot run the commerce class without the others. But the most important thing is that I have extremely untestable code here. And this is unfortunately, I'm not going to say unfortunately, it's unfortunate because not of the concept of testability, but because of the stupid zealot community of TDD zealots. Have you guys run into any of these guys? These are the guys with blogs that say red, green, refactor, I am test-driven. They put a banner on their blog that says, I am test-driven, because you are an idiot if you are not. That's more annoying than baby on board. It is. I'd rather have the baby on board on my blog. So the reason that this is not testable, though, is very valid. It's a very valid complaint on their part, and that is, if I'm going to write a unit test, I would have unit tests against my billing processor class so I can actually test the processing of a payment. That's a unit test for that class. But remember, a unit test is a very focused test for a single unit of work. So here, if I wanted to write a unit test on the commerce class, I'm not necessarily testing the successful processing of a payment or the updating of customer database records. I'm testing the successful execution of the process order without error. And if something's supposed to be returned in process order, which in my case it's not, I want to make sure that something gets returned and it's the proper something. Not that the database is going to get updated properly. That's not the purpose of that particular unit test. Those are other unit tests. The problem here is that I can't unit test my commerce class without instantiating these. And if I would have written these as production applications or production classes, what's my billing processor class going to do? It's going to run a credit card. What's my customer class that does the update customer order method going to do? It's going to update database records. So every time that I run this unit test, I'm going to undergo all of this stuff. So everybody sees the problem here? So this is the problem space that we're trying to solve, and this is why the first step towards going the route of dependency injection is to set the groundwork for it. And the groundwork for dependency injection is always about decoupling your code. And the quick difference between this and a decoupled example is that now I have all my same classes, but these classes now are implementations of the interface. iBilling processor in this case, iCustomer in this case, and so on and so on. I won't bore you with details that you probably already know. So now my interfaces are here. My interfaces simply provide the definition for that or those methods if there were more than one. And now the difference in the commerce class starts to look a little better, because now I have a commerce class that's dependent on interface-based arguments instead of concrete class-based arguments. If you don't take anything else away from this session, please take this away, because forget about DI containers, forget about dependency injection or inversion of control. This is the number one thing to let you write testable software. Because now my production application can instantiate my version of the billing processor and customer and notifier and logger classes that do actual billing processing and customer database update and all that stuff. And when I run it, it's going to do exactly what I expect it to do. But now my unit test, can instantiate the commerce class and send its own implementations of those classes. Implementations that are designed specifically for testing purposes. So now during a unit test, I'm not hitting the database. I'm not hitting a payment gateway like CyberSource or Authorize.net that's going to run your credit card through. I'm not truly updating the application log for logging, or sending out an email for notification. I may do somewhat test implementations of that by maybe sending out an email to an admin saying this test was just run, but more than likely I'm not going to do that. I'm probably going to run something called mocks. Anybody work with mocking tools here? Which ones do you like? Anybody use MockQ? Okay, that's what I use. Anybody use RhinoMocks? Equally good. What about Just Mock from Telerik? Very good one also. They all do about the same thing. Once again, it's just like the DI world, right? The minute one company adds features to it, the others hurry up and catch up because they don't want to get left behind. So choose the mocking tool that you like. So let me show you what a unit test for this would look like, because now we've written a class that is completely decoupled from its dependencies. Now, in the host application, I still have to instantiate this class, and I have to give it instances of those dependencies. And in this case, I'm instantiating the dependencies in a concrete way myself, and I'm injecting them in the constructor. This is where the term dependency injection comes from. And this particular flavor of dependency injection is referred to as constructor injection. And it's the most common way, because you're just instantiating your dependencies and throwing them into the constructor there. Other forms of dependency injection are property injection, which is exactly what you're probably thinking that it is. You just declare these things as public properties and you set them later. But now you're doing things in more than one step. So it can get a little uglier in code and a little more subject to risk, because now you run the risk of forgetting to set a property. Whereas here, it's very easy to not forget this because you're not going to be able to compile. And compilation is our first unit test, right? In a lot of cases, it's our only unit test, right? Shh, I didn't say that. It's like exception handling, right? What's our favorite way of exception handling? / to do. Yep. We have some / to do's in our system. All right, so this is what my production application is going to look like. But now let's test the process order from a unit test. What would that look like? Well, what I can do is that I can use a mocking tool. Now, I'm not going to get into the details of MockQ because, honestly, I'm not qualified. Sometimes I don't use MockQ in a month, and then I forget what the syntax is like. But I kept it as simple as possible. Here I'm setting up mocks of iBilling processor, iCustomer, iNotifier, iLogger. To any of you that are new to mocking, that are very new to mocking tools, go out and learn this and get one. I like MockQ, but get whichever one works for you. Mock tools are all about letting a tool set up a stub class that implements an interface. So all I'm doing here is I'm saying create a mock of the iBilling processor. So the mocking tool is going to create a test class that implements iBilling processor. It's going to do this all virtually. And then you can do whatever setup you need. Here I'm telling it when you call the process payment method and send to it either specific arguments, or in this case you can see that I'm saying send to it any string for those two arguments and any double for the third argument. I could also say returns something. In case I'm waiting for the process payment to return something, I can say set this mock up so that when you send these arguments, return something else. And essentially what I've done is that I've written a test class that implements iBilling processor or iCustomer. So now, once I have those set up, look what I can do. I can instantiate the commerce class and send to it the mock implementations. Now I can run my unit tests, and this is obviously a bullshit unit test because don't you wish all your unit tests were that easy? When is that ever going to fail in this universe? So I can call process order now, and what I'm doing is that I'm calling implementations that I set up here. I'm not relying on the concrete implementation of the billing processor that's going to run my credit card. I'm not relying on updating any customer records or any database records that are to increase identity, IDs, or anything like that. So this is the first step to writing, and it's the most important step to writing testable software, is set up the groundwork for dependency injection so at least you're doing it in concept and design, even if you haven't embraced the product yet. Everybody with me on that? Anybody have any questions? Because we've got to make sure that we understand this, because now we're going to take it up a notch. We're going to move into the product side of this, those pesky containers, as I call them. All right. Nobody's going to give me bad scores? Everybody want to see me back at TechEd again? All right. All right, so now, let's talk about what dependency injection containers are. Let me run back out here real quick. I can skip through a bunch of this stuff. What is that? Yep. How much time is wasted with this fade effect? How about just letting the slide come in? All right, so this is just a fancy way of describing what DI is, okay? So dependency injection is a formalized architectural pattern designed to satisfy these dependencies. It's exactly what I've shown you, okay? It's just a pattern of abstraction where classes are all abstracted away from their implementation to definition using an interface, and then the hosting classes receive their injected dependencies using that interface. And that usually involves a little more code. But when you're writing testable software, it always involves writing more code. You know, the days are gone where the only reason for having an interface is if you wanted to have more than one implementation of that interface. Now, it's very common in my world to always have an interface for every behavior-driven class that I write, always. Because that's the only way that I'm ever going to be able to test that class, is if whatever is using it is only using it by its interface. The minute that I'm not, and I'm going to show you another real-world example with another application that I have for a Pluralsight course that I'm writing on a lot of this stuff. But the minute that I am instantiating a class from inside another one, I take a step back because I think I've made a mistake. And this sounds like a pretty extreme statement because we've been programming for a long time. Most everybody here probably has at least 10 years experience, and we're all very used to doing something as simple and as common as writing a class, putting a method in that class, and then instantiating another class. We can't do that anymore. Otherwise, we can't properly test our software. And that's just become too important and too mainstream today. Everything has to be interface-driven. So you'll never see me instantiate a class from another anymore. Everything that I do is just like you saw it, where I have all my dependencies of a class going into it are coming into that class through an interface. And guess what? That other class that came into it, let's say, for example, iBilling Processor has an implementation class called Billing Processor. If that Billing Processor class also depends on other things, if it needs to instantiate other classes, they're going to come into it using interface definitions as well. Does that make sense? Now think about the complexity of that, because now it sounds easy enough, okay? I got my commerce class, depends on iBilling Processor interface, so I can send to it an instance of Billing Processor. But now somewhere in the Billing Processor class, I'm going to be instantiating two other classes. Well, I can't do that because then I can't test it properly. So now the Billing Processor class has to receive its dependencies through the constructor using interfaces, right? So now to instantiate Billing Processor, I need to instantiate two other classes, send them the Billing Processor. Now that I have Billing Processor, I can send that using the interface definition into Commerce. But there's a lot of instantiation going on there. You see, I have to keep backtracking. Where did all this start? What came first, the chicken or the egg? I started way down to Billing Processor. I got to satisfy its dependencies first. And now that that job is done, then I can take Billing Processor and use it to satisfy the dependencies of the class that's going to use it. You see how things start to get more complex when you talk about instantiations and where these instantiations are coming from? This is where a dependency injection container really starts to shine, where you don't have to worry about these instantiations. And that's what I hopefully am going to sell you on. And we have till what time? 4, right? Is this the last session? It is? Oh, well, that's cool. So then after this is nothing but booze involved, right? Excellent, excellent. All right, so the DI container is basically a repository to assist us in everything that I've been talking about. Now, I'm going to keep DI container usage to its absolute basic in this session, and I guarantee you I'm not doing that because I want to insult your intelligence or I don't think you're smart enough. I'm doing that because I don't want to waste your time, because everything that I'm going to show you about using DI containers is going to be what everybody in this room is going to be using it for 99% of the time. The other 1% is where you start to use all these special features that a lot of DI containers put into their product. But at its basic form, a DI container is all about two things, R&R. What does R&R stand for? Registry and resolve. I was thinking somebody's going to say, what does the R&R in the military stand for? Rest and relaxation, right? Somebody always has to be a smartass and say that. Registration and resolve. A DI container is really nothing more than a bucket of key-value pairs. It's a repository. And it's a repository for you to, up front in your application, at the beginning, When I say at the beginning, I mean literally at the beginning, and it's done one time. In a desktop application, normally this would be done in a splash screen. In a web application, it would be done at application start or on session start. And what I'm talking about being done is the registration process. This is where I'm going to set up a repository to associate an interface to a class. And I'm literally just going to tell the container, here's a pair of things for you, an interface and a class. Create an item for it and stick it in your bucket, in your repository. Here's the next one. Here's the next one. And at the end of the container setup, all I have is this literally this collection of key value pairs. And these key value pairs are nothing but associations of an interface to a class. If anybody has on the tip of their tongue, what if I want to associate one to many? Hold on to that. I'm going to cover that later on. Let's keep it simple right now. Who was about to ask that? Lying bastards. Oh, he was. All right. So I always get that question. And it's a very valid question, but I'll cover it later on, okay? So at its basic form, we're talking about associating an interface to a class. Now, apply that to everything that I just showed you. I showed you an example of decoupling class associations, right? Now, what associations can you think of already that apply to the examples I've shown you? iBilling processor to the billing processor class. iNotifier to the notifier class. iLogger to the logger class. And iCustomer to the customer class, right? Those are the 4 associations I can think of. In using a DI container, I would perform these registrations up front, and then I would write my code exactly the way that I just showed you. Because I showed you how to write code in a decoupled fashion. So we wrote a commerce class that was decoupled from its dependencies because it works only with interfaces. So this commerce class is not going to change at all. What's going to change is the usage. Because now if I go to the program class, here I'm not using a DI container. So I'm 100% responsible for instantiating the commerce class. But before I successfully instantiate the commerce class, I have to know what its dependencies are. I have no choice there. The compiler tells me so. So I have to instantiate billing processor, customer, notifier, and logger. Now, what if customer had 2 dependencies on its own, based on 2 different interfaces? Now, you would probably expect to see, if we're following this code pattern, you'd expect to see new something else right here, comma, new something else, right? Now, what if I'm going even one level deeper? You see how this can start to get really ugly? It can start to get very, very ugly from a code maintainability standpoint and just from a code prettiness. Because we all know it doesn't matter if the code works as long as it looks nice, right? So let's bring a DI container into the mix and see how we can solve this problem, okay? So I have a DI container of my own here. Now, I'm not out to sell you on this because I don't use it myself. I wrote this for the purposes of this talk. Now, I've done this talk several times in the past at other conferences, so it's not brand new. And this is where I'm going to digress into a short story. But I do want to show you how the container works from a syntactical standpoint, because the first thing I want to show you is that my classes are set up the same way. There's the class, and there's the interface that they implement. If I go to my commerce class, do you see any difference here from the previous example? It looks exactly the same. So now let's go to the usage, because that's where the key is when you're kicking off that first level class, the commerce class, the class that you want to do your work from. Sir? You've got a concrete class in your process order. Is that just... Where's that? Oh, but that's just a data class. Okay. Dependency injection is not about data, it's about behavior. So let's go over to the program class, and let's see how this works. Now look what I'm doing there. This is that first R in R&R. This is called registration. This is what's done one time and one time only, so don't be afraid of it. Don't think, oh, shit, I got to go through this several times. No, you got to go through this one time while your application is in that little please wait while I'm loading stage. I instantiate a container, and I build key value pairs. You see how it breaks down to very, very simple things. All I'm doing is that I'm building a bucket of key value pairs, and I'm telling it, associate this interface with this class, this interface with this class. Let me explain to you what that means, because this is the key here, okay? The key is that because of this container, I no longer have to go out and create an instance of the billing processor. I could now ask the container, give me the class that is associated with iBuilding processor. And what do you think the container is going to do? The container is going to instantiate that class and give it back to you. And if I tell the container, give me the classes associated with iNotifier, it looks in its repository, and it finds that, and it instantiates that, and gives it to you. But that's way too simple. There's got to be more value added to this, right? Yes?
How do you handle classes that take, I guess you pass the constructor arguments when you grab the register, grab it out of the register?
No, that's what I was about to. You're like one sentence ahead of me.
All right.
So doing that alone does not add enough value because I've clearly added some code to my application. I've added a little bit of overhead here. There is some reflection involved, so I better get a little more return on my investment to make this worth my while. So that process of telling the container, please give me the class that implements iBuilding processor and it returning this, that's called the resolve process. That is the container resolving this interface for you. This resolve process is actually quite magical because this resolve process happens recursively. So what happens when you ask the container, give me resolve iBuilding processor for me, it goes out to building processor class because that's what it finds in the bucket list, right? And before it instantiates building processor, it uses reflection to look into its constructor. And it looks for its arguments. And any arguments it finds that are interface objects or interface types, it goes back to itself, to the container. Remember, this is the container doing this. It goes back to the container repository and sees if they have been associated with anything. And if they have, it instantiates those classes and injects them into the constructor automatically. And guess what? For each of those that it just did, it performs the exact same process. So remember when I told you this was starting to get ugly because we're starting to go like 3 levels down or 3 or 4 levels down? Now it's not ugly anymore because now we're not the ones instantiating this stuff. Now I've just told the container, resolve this for me. You could also tell the container, resolve a regular class for me, even though it's not in this list. And this is what I've done right here. I've told the container, instead, notice the difference in code here from the last example. I'm not instantiating anything. I'm telling the container, create the commerce class for me. But now what I've done is that I have pushed the responsibility of the creation process of the commerce class to something else besides me. I've let something else take over the instantiation of the commerce class. I've inverted the control of the creation to a third party. And that's where the term inversion of control comes from. Yes? I'm sorry?
What if you need to dispose of it?
You're on your own. This has nothing to do with disposability. Once you have this class, its lifetime depends on you and your usage. You may implement the disposable pattern there, and then it's up to you to dispose the class. So that doesn't change whatsoever.
What does it do with value types? So let's say in customer, you've got name. And so what does it do when it instantiates customer?
When you say you've got name, you mean like in the
Let's say it's got a constructor.
in the constructor. Okay, so basically, it's an easy answer to that. Any type that the container cannot resolve, it puts a default value in there. So if it's a string type, it's obviously going to be a null, because we know that string types are reference types that have a costume on it that says I'm a value type because they're lined through their teeth, right? And if it's an integer, we know that it's going to get a 0. So there has to be a certain amount of responsibility on your part as a developer to write this stuff the right way. You know, there is no, if you try to build a better mousetrap to solve everything, what's going to be the end result? You're going to, if you try to make something idiot-proof, is the term, you're just building a better idiot. So here what I'm doing is that I'm saying create this commerce class for me. By me inverting the control of the creation of the commerce class to the container, what I've done now is I've told the container, not only do I want you to give me an instance of the commerce class, which should be easy enough, but I need you to execute the resolve process, kick off the resolve process down the recursion chain. So look through the commerce constructor and see if there's anything there you got to resolve. And of course, to resolve any dependencies for commerce, it's going to look back on its own contents. And for each one of those dependencies that it's resolving, it's going to try to resolve its dependencies. And this can be 2 levels deep. This can be 200 levels deep. If this ever needs to be 200 levels deep, you're on your own. Don't contact me for help. Okay? Actually, for a negotiated rate, you can contact me for any help you need. But you understand, are you starting to see the beauty here? This one statement right here is going to resolve everything down the chain. And by the end of the day, when we get the commerce class instantiated for us and returned in that variable right there, it's going to be nicely packaged with all its dependencies resolved and all of its dependencies resolved, and so on and so on. So no more worrying about where all this instantiation has to start from. It gets taken care of for us automatically. Now, like I said, there is a certain amount of responsibility on your part as a dev, because obviously, if you have more than one constructor, containers get confused. Some of them will blow up on you. Some of them will use the first constructor it finds only, which means the second one, if that's the one you intended to use, you're screwed. Some of them are attribute-driven. Some of them will use the constructor you decorate with a certain attribute. So that's where the different containers start to differ. Each one handles those kinds of exceptions in their own way. Now, I'm going to give you a reference at the end of the session that's going to help you out with any questions you have on specificities of each container. And it's where I got all my information from. And it's a book that I still refer back to. It's a brilliant book. It's the only book on this topic for us .NET developers. But everybody with me so far? Now, this is dependency injection and container usage in its most simplest form. But this simplest form is 99% of your needs right there. This container that I wrote is right here. And it's for you. You can have it. There it is right there. That's the whole container, 82 lines. There's my recursive process right here. And everything else that I'm going to show you really just builds on this. And it varies this mainly in syntax. If I show you Unity right now, which I will, and I'm going to show you Castle, and I'm going to show you Ninject, and I'm going to show you Structure Map, you're going to see that the only difference between these containers is 2 things. First of all, this code and this code, slightly different syntax. The other thing you're going to see is that some containers like you to register any type that you're going to want to resolve later, even if it's a concrete type, which means that type has no association to an interface. But it may still want you to register commerce. Just like that, just so it can know about it ahead of time. Why they want you to do that, I have no idea. Obviously, I didn't give my container that requirement because I didn't need to. So I don't know why Castle requires that. But some of them do require it, but it's not a big deal. Everybody with me? Now, I wrote this container for the purpose of this session about 2 years ago. And I gave this session at a conference in Las Vegas a couple years ago, and I had a group of developers from a bank in Mexico City. Anybody here from Mexico City? Good. All right. Oh, you are from Mexico City? All right, you were not one of those developers, were you? All right. So it was a bank in Mexico City, and these guys came up to me afterwards, the last session of the day, and we had a good time, and started speaking Spanish. And they were telling me that they love what they saw, they loved the session, but they're in a little bit of a bind because they got this application back in Mexico City where it's written, you guys ready for this? In .NET 1.1. I love that reaction. Let's try it again. .NET 1.1. Socks, don't it? Big time. I start to cringe, you know. So they can't upgrade it. You know, everybody here that works in political corporate environments knows how difficult it is to bring new technology into an environment, right? You got to fight a lot of wars that are sometimes not worth fighting. So these guys need to continue building on this application and adding functionality to it, but they can't upgrade the framework because they're kind of stuck on this for whatever weird and stupid reasons. So they wanted to know if they can adapt my container, because the problem with containers today is that you notice they're all generic based. And that's the number one thing that we got in .NET 2.0, right, was the use of generics. So they wanted to see if they can adopt my container to work at the bank. So with that in mind, I put this method overload here, and I told them, go ahead and take it home, get rid of this one, and just use this. And you should be able to do it, because it's just a type of, right? So it should work just fine. So I get an email a while later, like a week later, saying that it worked and they were using my little poor man's DI container in the bank in Mexico City. And they were very thankful. And it was good. It was flattering to me. So I'm on the stage a year later. I'm in a place called Sofia, Bulgaria. Any Bulgarians in here? All right, we can talk shit about them too. So, any Canadians in here? So I'm telling this story on stage in Bulgaria, and as I'm telling this story, I'm kind of, spicing it up just for entertainment factor. And I said, yes, a bank in Mexico City, and it's probably used to launder drug money or something, right? So I made that very politically incorrect comment, right? No offense. So the problem is that there's people in the room, and they got these things. And and I told them, that my container helped them out. And at the end of the conference, I'm on stage with the .NET Rocks guys, and we're doing an interview on stage. It's like 400 people in the conference behind me. And they all start laughing. And I'm wondering what the hell they're laughing about. And I turn around, and what's happening is that behind me, there's this giant, 200-inch screen that has these Twitter bubbles that are just showing up randomly on all the tweets that have occurred during the day, right? And on one of them, it said, Miguel Castro is helping launder drug money for a bank in Mexico. So I was watching my back for about 12 months after that. I thought it was funny. I didn't care for the wording of the tweet, but it is what it is. I can't do anything about it. So I thought you'd enjoy that story. But I'm not here to brag about this DI container because I don't care if you use it or not. I want you to use one of the good ones. This is just a piece of junk that I put together for this session. But I just want you to understand that it's a very simple concept, and it was very simple for me to write. And it's all about just asking for a type and then going through and using reflection. And they all use reflection. So if you got a fear of reflection, or if you're one of these die-hard anti-reflection guys, either get over it or learn another way to do it, which is going to be a harder way. Because, right, well, reflection is like anything else, right? It all depends on the value that you're adding. And if you're adding as much value as I think you're adding with this, I'd rather take the nanosecond hit that the average human eye is not going to be able to discern when they're looking at the screen. You're not going to tell the difference. So it is going to use reflection, and it's going to go through, and it's going to resolve dependencies, and it's going to do it recursively. And it's going to be a very, very cool thing, because you don't need to worry about instantiation anymore. Let me show you what the difference between the containers are, okay? Now, this is my container. As you can see, I'm doing my registration, which once again is nothing more than setting up key value pairs of these associations. Now, I want you to keep on the back of your mind the term associations, because that's going to be very important when I start talking about MEF in a few minutes, okay? We're associating interfaces to concrete classes. And we're storing this association in a bucket somewhere so we have access to it. So then later, when I execute the resolve process, I can depend on that list of associations to resolve every dependency of the class, the top-level class that I am asking for. Now, this is my container. Let's take a look at another one. Let's go over to Unity, Microsoft's Unity, which is a great container. Anybody see any similarity in this one and mine? Almost identical, right? Except this one says register type instead of register. And then look at the resolve process. I think mine was called resolve as well, right? Or was it called resolve? There you go. So that's Unity, but it's doing the same thing. Exactly the same thing. Let's go over to structure map. Some guys tend to think that using lambda expressions just to confuse somebody makes them look smart. It's doing the same thing, just a different syntax. Now, the reason for the different syntax has to do with richness of the product. So when Jeremy Miller, very smart guy out of Austin, Texas, wrote structure map, which incidentally was the first .NET dependency injection container on the market as open source, he used this syntax because he gave it a lot more functionality. So obviously, there's going to be in the IntelliSense a bunch of other things that you can do with Reg and other things you can do here. So this is called a fluent interface. And this is where the DI containers differ from one to the other. This is where you can give it more detail. For example, what to do if you encounter more than one class associated with this interface, or more than one interface associated with a class, or a class with multiple constructors in it, or a class with a string constructor. What do I put here? You can actually tell it in this fluent language. If you find a constructor argument called name, use the following class to plug in, or the following type. Each container does things a little differently. But there you're getting into stuff that you're probably going to use less than 1% of the time. But as you can see, it's doing exactly the same thing. And look at this. Jeremy decided to call it getInstance. Let's look at the next one, Ninject, very popular container also. You see? It uses a bind statement. And there's the get. What about Castle? Castle went full tilt boogie on complexity, right? But ultimately, it's still the same thing. Now, what's the number one thing that you're seeing that's different here with Castle and the other ones? Castle's requiring me to register the commerce class as well, because I'm asking for it down here. And without doing that, Castle just barks at you. Why it forces that requirement? I'm guessing because now I've opened up the possibility of adding more functionality to the resolving of the commerce class here, which may be something that I want. But Castle forces you to do that whether you add extra functionality or not. But the end result is the same. I got these 4 associations, and I'm resolving the commerce class down here. So you see how they mainly differ just in syntax? If you want to keep things in the Microsoft world and you want to just rely on the stuff that Microsoft, there's a lot of shops out there that just are really diehard, very strict with, we got to do it this way because this is the stuff that we get from Microsoft. And that's perfectly fine. I'm not here to criticize that. Use Unity then. It's a great container. And it does a lot of the stuff that these guys do as well, if not all of it. Now, there's another product that Microsoft has that, in my opinion doesn't count. I'm just a lowly dev. Should actually be merged in with Unity, and that's MEF. MEF is Managed Extensibility Framework, and it's actually a plug-in and add-in framework to add plug-in functionality to your apps. But it does so by providing you with a dependency injection container. And in doing so, in my world, satisfies 99.9% of all of my dependency injection needs. Now, the way MEF works is just slightly different. Let me show you the way MEF works. Now, I got these interfaces. I showed you these interfaces, right? They haven't changed. Now, in none of the other examples, the classes haven't changed either. However, with MEF, there's a slight variation to the class. Anybody see what it is? There's an attribute there. MEF uses the discoverability process. That's really the main difference here that I want to portray to you. Whereas the other containers use proceduralness in the program class or in the splash screen or whatever to list out those dependencies, that's just that container's way of filling its bucket list. A lot of those containers also do things through XML files, like Spring, and even Castle allows this, and I think all the other ones do at this point too, where I could take that whole list of dependencies that you saw that I had in 4 lines of code and put them in an XML file. Then I can tell the container, build yourself by pointing it to that XML file. And it's doing the exact same thing. It's just getting the information for the associations, there's that word again, from an XML file instead of from procedural code. Well, MEF varies in the way it gets its association information. So here I'm saying I have a class that implements the iBuilding processor. I want to export that class and associate it with that interface. There's my registration right there. There's my association of the class to the interface. Because MEF works through a discoverability process, where later on in my splash screen, instead of listing out associations, I tell MEF, here's the following assemblies I want you to go look at. Go load those assemblies, reflect through the types, and find types that are decorated with the export, and put an entry in your repository based on that information. It's just a different way of obtaining the exact same information, which are associations of interfaces to classes. Now, who's wondering what that second ugly attribute is? So that's the thorn in our side, and it's going to be the thorn in your side, because there's a lot of crack technicians at Microsoft. There's a lot of crack smoking technicians at Microsoft. And it was one of those, in his infinite wisdom, that decided that the default resolve for a class using MEF is going to be the singleton pattern, which means that once you get the class resolved for you, next time something resolves that same class, it's going to use the exact same instance. Now, we all know that the singleton pattern has two pieces of information about the singleton pattern. Number one, it's the very, very first pattern in the very, very first chapter, very first page of every patterns catalog in the world. Number two, it's the very, very last pattern that you want to use unless you absolutely need its services, okay? So it's the easiest pattern, but it's also the most dangerous one. So to avoid classes being resolved using the singleton pattern in MEF, you have to give it this non-shared value on this attribute. And when you forget to do this, you know, it's like the clouds will cloud over and an F5 will occur and dogs and cats will live together and all sorts of weird crap that will wreak havoc on your application. But as you can see, the rest of my classes here just have those associations there. So now my program class looks a little different. My program class doesn't have those associations listed. My program class now is going to build a catalog of assemblies. And you can build a catalog, you can build one assembly catalog or a bunch of them using something called an aggregate catalog, which is what I've done here. I've created an aggregate catalog, and I'm adding to the catalogs collection a bunch of assembly catalogs. And there's different types of catalogs in MEF. This is an assembly catalog, meaning I'm going to take whatever, in this case, the executing assembly, and I'm going to create a catalog out of it, of every type in that assembly. I could also give it a folder catalog, which means I can point it to a directory path and now say, everything in this folder, I want you to go out and look for it, which is great because now we don't even have to reference the types. So you can actually, this is where the plugin pattern comes in, right? Where you can just dump new DLLs into a folder without going back to the host and recompiling, which is really cool. That's true extensibility there. And then all you got to do is tell MEF, build a container. Once you do this, that line of code on line 18 there, that's what tells MEF, go through every assembly in the catalog and start that discoverability process so you can build your bucket, your list of key value pairs. Make sense? And then the rest of it's the same. The syntax is different. Get exported value right there instead of get. Now, MEF offers one thing that used to be very unique to MEF, but now it's my understanding that most, if not all, the containers offer this, okay? But it's very, very important in certain situations. And that is, if we go like 5 minutes over, is anybody get pissed off? No? You guys are not in a hurry to go drinking, right? So MEF offers something called post-construction resolve. Now think about the resolve process that I taught it to you as I described it, okay? The resolve process has to do with right before you instantiate a class, through the container is going to try to satisfy the dependencies. Well, that satisfaction of the dependencies, that resolve process, you could also do it to an existing class, which means as opposed to what you're seeing on the screen here, which is create the class by going to the container and saying, get me that class, and at the same time kicking off the resolve process, what if I wanted to do something like this? What if I wanted to instantiate the class myself for whatever reasons? I'm going to give you a good one in a second. I want to instantiate the class, and now that I've instantiated the class, I want to then kick off the resolve process. Post-construction resolve, meaning I have an existing class that I could not get through a container for whatever reason. I could not get this class through the container, but I still want to incorporate the class in dependency injection. And not get it confused, because I can tell it, use this as the importing constructor. Now, in MEF, I could also do something called setter injection, where instead of using the constructor, I could now take members, and they don't have to be public, and I can mark those members with the import attribute. Because now, when the resolve process is kicked off, MEF will know to try to resolve this argument. And in this case, look what I've done. I have a regular default constructor, and I'm saying, go ahead and kick off the resolve process. When I built the container, I put the container in a static variable that's global to the app. That's very normal. So I have it inside my program.container property. So I'm going to the container, I'm saying resolve this class. Now that the class exists, something else instantiated this class, I want you to start the resolve process for me. And then MEF uses reflection. We're already past the constructor phase, so it can't look at the constructor. But it can look at the members and find the members that are marked with the import class, with the import attribute, and resolve those dependencies. And once again, recursively finish off that in the line. Now, who's a WCF developer here? Okay, this is your quintessential example of a situation where something else is going to instantiate a class for you. You can't do it through the container. What instantiates WCF services? The WCF runtime. Now, who says that you can't let WCF instantiate a class, but now you can have dependency injection on that WCF service? And I have that situation here.
Well, that's starting up one of the main questions or issues that people have with dependency injection. When you're trying to step the code and you go to definition, you get the interface class or the concrete class. Do any of these help with that?
I think you would go to the concrete class when you step through it. I don't know if, why would I go through the interface? The interface is not an execution.
But right now, if you're in the method or you're calling new I behavior,
Okay.
when you right click on that to go to definition, it's obviously going to go to the interface.
Oh, I see what you're saying. Now, I think it's still going to be like that. All right, check this out. This is a WCF class. Anybody that works with WCF is probably familiar with that service behavior attribute, just as proof that this is a WCF class. Now, check out what I got here. I have a default constructor. This is the only constructor that WCF is going to care about, the default constructor. But I got two dependencies here. I have a data repository factory and I have a business engine factory. And I've injected them using MEF. Why? Because in my base class constructor, I'm saying kick off the resolve process. And how do I properly test my WCF service now? That's where all my other constructors come in. Because now, if I have a method that I want to test in the service that's dependent on the repository factory, I can use that constructor. If I have one that's dependent on the business engine factory, I can use this constructor for my unit test. If I have one that's dependent on both, I can have this constructor. I can have as many constructors as I want. WCF doesn't care about that. It's going to use the default only. The rest are only here for my own unit testing purposes. Because WCF is always going to inject this stuff down here using dependency injection, whereas my unit tests are going to inject all this manually using mocking. Understand how that works? Now let's go through a couple of implementation examples, and then we can call it a day. Everybody liking what they see so far? Yes. Cool. Now, let's stick with MEF, and let's go to the first one, which is quite simple, which is my WPF example. Now, my WPF example is using dependency injection in two different places. The first one is going to be my view models. I'm using MVVM here. If anybody's doing WPF without MVVM, please do not admit it to me, because I'll blog about you, and the whole world will know what an idiot you are. All right? Did I just offend you? Good. Use MVVM. All right. You know where I'm coming from, right? You got to use the MVVM pattern to have any kind of good testability in WPF. You don't want to use the code behind. So I have some views set up and I have some view models set up. Now the first thing that I did is that, just let me explain to you what this application does. It's got two views. It's got one main view and then a button. And the button just toggles between two different views, a customer list view and a customer detail view. So when you hit the button, it shows you the customer list with 4 customers. I didn't want to make it complicated, so I just let you click one button, and it toggles and shows you that one, the first customer in the list. So all I'm doing is that main view has 2 properties of view model types using a base class that I have called viewModelBase. And all I'm doing is that I have a property called currentViewModel, which is being bound to the content area. That's all it is. Who's the WPF developer here? Or Silverlight? So then when I press the button, the property that that content area is bound to is going to be one of the other two view models. All I'm doing is toggling them. If it's this one, set it to this one. If it's this one, set it to this one. That's it. Very, very simple. And then I'm using data templates to do the view association. That's all. So if I go to the main view here, you'll see that this view model inherits from view model base. Also notice that this view model is being exported, which means it's going to undergo container usage, but it's not associated with any interface. Which means that something is going to ask the container for this class, so it needs to be exported. And then here's the constructor, and here's the dependencies. A property called customer list view model, a property called customer view model. They're both two different view models, and look where they're coming from. They're being imported through Meth, which means that if it's Meth that creates this view model for me, the main view model, Meth is also going to find these and resolve them. So by the time whatever asks for the main window view model receives an instance of main window view model, it's going to get it in all its splendor, fully loaded with the other two view models in place, because then there's the toggle view command that just flips between the two. And then if I go to these other view models, look what they look like. They're exported as well, which means they're going to undergo Meth usage. But now take a look at their constructor. Now these view models are designed to actually expose some model information, which is going to display on the screen through XAML binding, which I won't get into now. But as you can see, I'm importing the constructor there, which means when Meth instantiates this class, it's going to see that constructor and it's going to want to resolve it. So when it tries to resolve that constructor, what's it going to run into? iCustomer repository. Well, hopefully, it knows what the hell to do with iCustomer repository, and that responsibility is mine. But I do have a class called customer repository, which has been exported and associated with iCustomer repository. So here's an example where I'm going 3 levels deep. I started at the top with main window view model. Main window view model contains 2 resolved view model properties, and each one of those has references to the customer repository, but always by way of an interface. Where is it? Always by way of an interface, which means I can write a unit test against this class and just implement this using a mock. And I'm not really hitting the database. Not that I'm really hitting the database in the production example, but you get the picture. And then the main window view model. I can write a unit test here. In fact, I could have chosen to put these in the constructor. It would have been just fine. 6 in one hand, half a dozen in the other in this case. And then the main view, my main window view, which contains the main content control for everything, is the only view that has one line of code in the code behind. And that's kick off the main view model for that main view, because everything else down the line gets instantiated by way of dependency injection. So all I did is I instantiated the view model to bind it to the data context of the view. The key here is how I instantiated it. I didn't instantiate it. I told Meth to go get it. Because by telling Meth to go get it, I've kicked off that resolve process down the line. And I've resolved all the way down to the customer repository. So then I got a nicely filled view model with everything that I need. And there it is. Toggle to detail, back to the list, detail, list, detail. Easy enough? Who is a ASP.NET MVC developer? Okay, dependency injection is extremely popular in the world of MVC. I'll show you where. When you give a website that's written in MVC a URL, remember, part of MVC's job is to dissect that URL to determine what's your controller and what's your action, right? And then it goes to something called a dependency resolver to take the name of that controller type and instantiate it. So what you can do with MVC is you can tap into that process by replacing the dependency resolver with one of your own. And the default dependency resolver simply instantiates the type. My new dependency resolver is going to do what? It's going to go to the container for the type. That's the only difference. So now the key is all about making sure that all of my controllers are exported. And as long as they're exported, any dependencies that my controllers have, in this case, customer repository, can now be injected into the constructor. I mark it with importing constructor. And now, as long as I have my dependency resolver, and I do have my dependency resolver right here, and as long as I install it, which I'll show you in a second, this is the type, this is the object, the method that MVC is going to call to get the controller instance based on your URL. But in reality, it's going to call mine, which does not do an instantiation of that type. It goes to the container to get it. And by going to the container to get it, I instantiate this through the container. And by instantiating this through the container, I kick off the resolve process for this and any other dependencies I may add in the future. And there's a lot of cleanliness to not having to worry about where the hell am I going to instantiate this? Because the answer is you don't have to worry about it anymore. Remember, I said we're not going to be instantiating classes from other classes anymore because that blocks our testability. We're going to simply be receiving those classes as dependencies and letting something else handle the instantiation. That's the container's job. But now I can write a unit test to test my home controller. And anybody that's written MVC controllers knows you can actually have a unit test project created for you automatically with your site. And now I can instantiate home controller with a mock version of this. So then when I call this action, it hits that, and it's hitting my mock instead of my production one. Make sense? All right, one last one, and then I'll let you go, all right? But I want to show you one slide before you walk out of here. And thank you for sticking around. For web forms people, you do have some usage of this that you can do. But you need that one feature that I told you about earlier, post-construction resolve. Because like WCF, you can't delegate the task of creating the code behind, you know how you have the web forms, you have an ASPX page, you have a code behind page. And the code behind page inherits from the page class. Well, something creates that class for you to build that HTML. That something is called the page handler factory. Anybody ever hear of this? So the page handler factory is something that I've become very intimate with when I do ASP.NET talks. And it's a factory class whose job it is to mash up that ASPX view with the code behind view together to give you a class that's going to resolve to HTML. Now, Microsoft has spent a lot of research and time into doing this properly, and you don't want to upset that process. You don't want to do it yourself. You want to let them do what they're good at. So you've got to let the page handler factory do its job, and once it gives you that page, then you can tell it, please resolve my dependencies. So you see how I need post-construction dependency here? So what I've done is that I have this customer's ASPX view. There it is right here, and it's got a code behind class. Look what the code behind class looks like. Regular code behind class that's using a customer repository. And where's it getting that from? Well, I don't know. It's just declared. So hopefully that's being filled in by something, right? So what I had to do was that I had to override the page handler factory. By overriding the page handler factory, what I did was that I inherited from the page handler factory, and then I overrode the get handler. Now this line 15 right here, that's the key. That's Microsoft doing its job that it does so well, building that web forms page for you. So by the time I get that page variable, my page is built, and it's ready to be returned. And that's what the default page handler factory does. It does line 15, and it does line 21. All I did was stick something in the middle. So before I return that page, let's go ahead and satisfy the imports. Let's start that kickoff, that resolve process. As long as I exported my associations properly, I can kick this process off. And what I've done as the end result is that I've given you a web forms that fully has the capability of dependency injection. Now, I still don't have the testability of this code behind that I have with MVC controllers because that's just a shortcoming of web forms. But I still have dependency injection usage, so I get a lot of code cleanliness here. And I don't lock myself into this one implementation of the customer repository. So I still get some value out of it, albeit it's not as much value as we do with MVC or with WPF, but you get some. So the rest of these slides have like all this reference stuff, everything that I talked about, all the different containers. Look at this. I'm hitting space really fast, and it can't keep up with me because of there we go. Okay. Okay. This is the reference that I want to show you. See this book right here by Mark Seaman? Is this man in this room? No? I don't know who this guy is. I've never met him. I'd like to meet him once and just shake his hand because this book's been a lifesaver to me. It's probably the best 20, 25 bucks you can spend. It's a Manning book, which is great because Manning books, you buy them once in paper and they give you a code in there for free. You can download the Kindle version. So you get both versions for one price, which is awesome because I like to keep the stuff on my iPad too, especially in full color. There is a chapter in this book dedicated to each one of the containers I showed you and then some because it also has Spring and a couple of others. And it's got MEF, and it's got Unity, and it shows you all their fluent language and all their shortcomings and all their features and all the differences. It's a full chapter on each container. So it's like, to me, it's the definitive source on dependency injection in the world of .NET and .NET containers. So I strongly recommend this book. I hope I've given this guy a good plug. He deserves it because he wrote a hell of a book. Martin Fowler described IOC, and I had to put a reference to Martin Fowler's article here because he's one of these guys that writes the phone book and people actually read it. But it's one of these topics that's just tons and tons and tons of info on the web. I want to make sure that you walk away understanding that this is no longer an auxiliary technology or a background technology. This is mainstream in its forefront, and it's something that you got to use in order to write testable software and in to write software that has maintainable code, because you saw how clean all this stuff is. I don't have to worry about this stuff. You know, that if I have another, as long as I export all the classes that I want to use and they have associations to interfaces, if I find a class that needs to depend on something new that I didn't count on before, I don't have to worry about where's this class being instantiated so I can instantiate that other one first. No, I just add a member variable, mark it as import, and I'm done. The container takes care of everything for me. I'm putting together a Pluralsight course. It's going to be out by end of July. It's called Building Multi-Client End-to-End Service-Oriented Applications. It's an end-to-end, probably about a 5 or 6 hour course. It's going to go complete soup to nuts from the database layer all the way to multiple clients, including desktop and MVC apps, including Knockout. It's going to incorporate dependency injection. It's going to show you a lot of these patterns. It's going to show you a lot of my repository patterns that I've come up with and that I use on a regular basis. So I hope that you check it out. It's going to be online by the end of July. You guys enjoy New Orleans, and I'll get drunk with you tonight, all right?